So here's the part list for my 3D printable Airsoft MP5. Some things to note here are that this 280 to 400 FPS spring option, personally I would recommend you use 300 to 350 because this is a gun for indoor, and therefore most places are going to limit it to 350, and anyways it's just better for the gearbox if you don't use a 400 FPS spring. Although I have tried and it does work, and I did run my gun like that for a year straight in some previous designs. Regarding these 2-pin tactile switches, you only need one of these. So if you have one lying around, you don't need to buy a whole pack from Amazon. For the MOSFET, the gate nanohard, if it's too expensive, you could use any other type of MOSFET that uses a Dean's connector and I guess two more ports for the control wires that will connect to the tactile switch. For the wiring for the motor, you want to get it as thin as possible, but you also don't want it so thin that you're limiting the power delivered to your motor. So 18 gauge is fine, 16 gauge is fine, just don't do 14. Now for this 2mm diameter carbon fiber rods, you don't necessarily need them. For the tappet plate spring, it is recommended because the tappet plate spring is pretty strong, so you want something that won't break. So you only need like one carbon fiber rod. So again, if you already have it, just don't buy it from Amazon because one is enough. For the rest like of the rods you're gonna need for like axles of rotating parts, they can literally just be made from a toothpick, and that's what I did. Now for like the other random springs, you're just gonna need some springs from a ballpoint pen. And if you don't have any Nerf guns to take apart, you could also just buy the whole internal spring set from this Lincoln e-bike. The batteries I use for airsoft are the same that I use for my RC airplanes, so that is why I guess I use Dean's. And I stress using Dean's connectors because they have very good wire contact and are able to deliver good amounts of power. Now for the magazines, you want MP5 mid caps because mid caps are much better at feeding without, I guess, jamming. And for the red dot sight, I put a link to Amazon here. It's pretty cheap, but it works very well. It has a clear sight picture, and the glass is very durable and will not crack when shot. So you don't need any red dot protector. Regarding the filament, I recommend you print almost everything with Super PLA Plus from Overture, as this has a higher melting point than normal PLA, while still being very strong and easy to print. For a lot of these flat, big parts, you want to prevent warping, and I just do this by having at least 3 lines of brim to ensure proper bed adhesion, as well as putting glue stick on the bed, obviously. Another thing you could do to avoid warping is use 100% fan speed, as you're using PLA and this should be normal. And print out slightly lower speeds than usual. Since we want the parts to be pretty strong, I recommend using 4 walls and at least 20% cubic infill. However, for certain parts, I'll just tell you what settings to use. Now, the gearbox plates, the names of the files are given right here. These face the highest stress out of any part in this airsoft gun design. I recommend printing it out of ABS. However, I actually got these two parts printed out of polycarbonate, and I just had a 3D printing service do it for around $20. And I used 4 walls and 100% solid infill. But as I said before, every single other part of this project was printed in Overture Super PLA Plus. And by the way, all the file names I put at the top of each slide, so it's very easy to know what part you're working with. So what you do, you just glue these together, make sure everything is symmetrical, and by the way, the glue that I use for gluing these PLA parts together is Bob Smith Industries purple glue, and it binds PLA very, very well. So once you glue the two parts together, you just slide in the hop feeder as so. Next, we print out right upper combined and left upper combined. For short, I'll just call each part right upper and left upper. You're going to want to print these with 4 walls and at least 50% cubic infill, since these parts need to be rather strong. Now you're going to want to put screws inside these holes where the cylinder goes, and you want around 5 millimeters to protrude. And the purpose of these screws is to keep the cylinder head from rotating while it's inside. Then take a 2mm diameter carbon fiber rod and glue it into this hole right there, and that's where the tappet plate spring is going to loop onto. Next, on left upper, you want to screw in the hop-up unit with a 1 centimeter screw. Now take a screw that's around 3 centimeters long, and you want to only partially screw it in so it lies flush on the right hand side of the hop-up unit. And you want this to act as an axle for the hop pusher part. And essentially, to get it to move smoothly, you can use sandpaper or just the X-Acto knife to shave a little bit away at the hole in hop pusher so that it spins freely as shown. Now on left upper, you want to unscrew that small fastening screw that was meant for the cylinder head, and this is so that you can test if it works. So just put your nozzle and cylinder head and cylinder together and slide it so the nozzle goes inside the hop-up unit. Then screw the fastening screw back in and just wiggle it around to see if it fits properly. Next, print out new L Magwell and new R Magwell. You want to print this in the orientation such that the parts that are touching each other while I'm holding it together are flat on the print bed. Print it with supports because you have a big overhang right there. And you just want to minimize warping as much as possible since they need to go perfectly flat together. And this part does not need to be that strong, so print, I guess, at least 2 walls and at least 15% infill. You're going to want to sand the inside where the mag goes, and to test if the mag fits properly, just clamp it together with your hands and fit the magazine to ensure that there is a proper, snug, but not too tight of a fit. For the magazine catch and release, print out Magwell lock and mag button. I just printed these with 100% infill because I wanted them to be a bit stronger, since obviously this is a part where more wear and tear can happen as the magazine slides in. Essentially what you do is you glue the nut inside Magwell lock, and you have a screw approximately 3 centimeters long which goes all the way down into that nut, and a spring can be put right there. So you just take a spring from a ballpoint pen and assemble it, and you're going to want to sand this quite a bit to ensure that it slides smoothly. When you're satisfied with the operation, simply put a dot of CA glue on the head of the screw to fasten it onto the mag button. After this, just test if it works. Once you have finished assembling the magwell, simply friction fit it on to the hop-up and ensure that it fits properly and tightly with the hop-up unit. For the handguard section, print the handguard with 4 walls and 100% infill. And for these tip rail and hop rail, honestly just do the same, though you can get away with 4 walls and 20% cubic infill. And screw hop rail onto the M-LOK handguard and then use purple glue to glue the tip rail on. Then take your barrel assembly and push it all the way into the hop-up as shown, and use hop lock to fasten it into the hop-up. And make sure that your barrel is in the correct orientation such that the hop-up window is pointed straight up. Now take your outer barrel and M-LOK handguard, slide them into each other, and slide the whole handguard assembly all the way onto the barrel. Now hold it in place and take your magwell and fit this on such that this extrusion fits in that hole and this extrusion goes right there. Now you want this magwell to hold everything together. Then take 2 of these 2 centimeter long screws, screw them into the handguard through the magwell. Then take 1.5 centimeter long screws and screw them through the hop-up into the magwell. Next, you're going to want to print out rear rail. Print it so that this face is on the bed and there's a support structure right here. Make sure there's 4 walls with at least 20% infill, and the infill should be cubic. Then take 3 screws and screw rear rail onto the left upper receiver. Now attach your tappet plate to your nozzle and put your piston in and put this whole air compression assembly in and fasten that fastener screw to the cylinder head. Now it might be a bit difficult, but hook this tappet plate spring onto the carbon fiber rod. At this point, you should have your piston able to freely move back and forth, and your tappet head also able to move back and forth, but obviously not freely because there's a spring holding it in place. And you should lubricate the rails on which the tappet plate and the piston go back and forth. Make sure everything goes smoothly, and if not, maybe try sanding the rails. Next, you want to attach the right upper and just pre-screw the screws and the fastener and just put it on and screw it down and make sure that your piston is not stuck anywhere and is freely moving on the rail still. For backplate, which is this flat part, print it so this face is down and make it 100% solid infill with 4 walls. For adapter, which is this block, you want it to be printed standing up, so the face over here, which you can't see but it's like pointing that way, that face should be on the print bed. Also with 100% solid infill and 4 walls. And back block, which is this part right here, should be printed so this face is on the print bed. Also, it should be printed with 100% solid infill and 4 walls. Take an M5 screw that's around 3 to 5 centimeters long and screw in your spring guide onto the backplate. Now take your MOSFET and make sure the wires are through the adapter and through the backplate. And of course, before you wire this through, you're going to need to slide the adapter onto your backplate. After this, you can solder the tactile switch onto these 2 small wires and also solder your motor contacts. Now you want to put the wires running through the back block in this interesting tunnel over here and put a screw from the back plate into this nut, which should be glued in. And it's okay if it's not super tight. It's okay if this is able to like spin relative to like the axis going through. Now the control wires, it's very tricky to get everything to fit nicely. What I first did was put the thin control wires for the channel and glued it in place. Now also glue it down right here in front of where the motor would go. And glue the tactile button right there, and you might need to put some spacers, so I just used some balsa wood to get a good seated fit. Now when I put the 2 sides of the grip together, I noticed that the motor was a bit loose, so I used some medical tape to create some spacers. And by the way, when you're printing new grip right and new grip left, you want this face that's showing to be on the print bed with supports. Though you don't necessarily need supports, I printed it and the bridging worked fine. And there's no need for sanding. And print it with 100% infill and 4 walls. Next, try to bend the wires to form them along the shape of the channels and just put them inside the motor contact places. Now you can clamp the 2 grips together and use medical tape to hold them together while you inspect to make sure everything is fitting normally. Again, you want these wires to be nicely inside the channel. You want the motor to fit nice and snug without being so tight that it's impossible to move back and forth. Once you're satisfied with the fit, simply just glue it together with Bob Smith Industries purple glue. And for me, I could not avoid there being a little bit of warping at the front and back of the grip. So I just used a little trick that involves taking some sawdust and putting it inside the gap and then using the super thin Starbond cyanoacrylate to basically create a filler material. Then you just sand it smooth and it looks perfectly fine. After this, just run a few drops of the Star Bond CA all the way around the seam to make sure the bond is perfect. After that, you can take off the tape and then put CA where the seam was covered. Put the trigger inside, and it doesn't matter which orientation you print the trigger in or how much infill you have, but I just printed it solid. Use a carbon fiber rod as your axle and glue it in. I didn't have any carbon fiber at the time, so I just used a toothpick and it works perfectly fine. Make sure that it moves freely, and when it's all the way down, it should be 1 or 2 millimeters above, I guess, this plane right there. Next, start printing your right gearbox plate, left gearbox plate, and GB 1 through 4. Now, I did not have pictures of when I put the nuts in or assembled this gearbox, because I actually made this gearbox around 2 years ago. And yes, this still works and has not broken down yet. So you're going to want to put nuts in these 4 holes. Also put nuts inside these spaces which I've shown with the arrows. And print these all 100% infill 4 walls out of your PLA. For the plates, the gearbox plate, as I said before, it's best to print it out of ABS or some higher temperature and stronger material. I use polycarbonate from a printing service and it worked out perfectly fine. For your anti-reversal latch, I made a hole where you can insert a carbon fiber rod which latches on to the anti-reversal latches spring. But back then I did not have it designed this way, so I literally just melted the wire into that plateau and it works just fine. Now glue each of these parts to each half of the gearbox, but do not glue the gearbox plates together yet. Instead, just hold it together and basically just, you need to shim your gears by pushing this inside your, pushing it inside your grip and just like wiggling your sector gear around to check if you're getting proper motor pinion to bevel gear contact. And of course, just shim. You can find these like shim tutorials on YouTube, and even though this is a different gearbox design, shimming in principle is the same. So after you're satisfied, just glue the gearbox halves together and lubricate everything with, I just use silicone oil, but you can use dielectric grease as well, and shove it inside. And of course, do not forget the motor spring over here. In this step, you just need to connect the whole upper of the gun with the grip and the backplate. So first, just put in your spring, and as I described before, you don't want to have an overly powerful spring, so your maximum FPS spring should probably be 350. I play with around 300 to 320 FPS, because in indoor you don't really need a high FPS. And also this prolongs the lifespan of your gearbox. So you just put in your spring and then just assemble it together as so. And once you've basically pushed it together, you want to put one 25mm long screw in the back plate that basically screws into this top rear rail. And put 2 screws for the back block, which is inside here. And then you could also put screws for your top of the gearbox, which attaches to the upper. And here's a video of me assembling the whole thing. The rest of this build is relatively easy and straightforward. First, download the stock STL and print it so that it's standing up. So the face that's basically pointing toward the ground in this picture is touching the build plate. And you're going to need to print it with supports. And for the other settings, have 4 walls as usual with 100% infill. Now you can see that here I carved in the rectangular hole, but that was because this was one of my first prototypes of this design, and in the actual file in the project, it already has the hole printed like that. So just slide the MOSFET and the wires through and partially screw in 2 screws. Then you're going to screw it into the adapter and then apply the purple glue to the stock. And this will fuse the stock and the adapter together very well if you just leave it standing upright like this to cure. Next, print out the removable stock plate and 2 of these stock slides. Print out the stock plate so that this face of the stock plate is down on the bed, and this doesn't need to be strong at all. So I printed it with 2 walls and 7% infill. For the sliders, print it so that it's face down exactly in the orientation that it's in sitting in my hand in this picture. Print it with 4 walls and 100% infill. And with supports, and be careful in the settings and make sure that you're allowed to print supports on the 3D print itself. Or you could just use tree supports, which will like branch over underneath. Once you print it out, do not sand it because you need it to fit relatively tight. Simply put it through and now put this onto your stock and then slide the sliders to their most outward position, and this should lock it in place. Next, for your trigger guard, all you need to do is print out the trigger guard file, then take a ballpoint pen spring, put it inside this circle hole and the other corresponding circle hole inside the trigger. This trigger was, again, one of my prototype designs, so it does not have any of those holes, so it's significantly harder. For you, it'll be very easy. Then simply slide the tail end of this trigger guard into this small space, and it should be a tight fit, and then fit the other side into the magwell. And just make sure your trigger is seated inside the indent. There's an indent on the other side. It's like a cage to prevent the trigger from moving sideways. And now you could put a carbon fiber rod because there's a hole on the magwell where you can put a rod through. I haven't done it yet, and I just plan to just put glue. Whatever you do, don't put glue both on the grip and on the magwell, since if you want to take apart the grip itself, then you're going to have to take out like the magwell as well, and that means you had to take apart the top rail and it just gets complicated. So yes, just put in an axle here or just glue it right there, and don't put any glue here. Now this is the motor plate with the shimming screw. Simply print it so this face is on the build plate. And by the way, this part right here is the grip plate, and this like cylinder that's protruding is a separate print, so you don't need any supports. Print it with 4 walls and at least 20% cubic infill. For the grip thread, which is the cylinder part, and the grip screw, print those both standing upright with no supports and with 4 walls and 100% infill. Then sand the outer edge of the grip thread so that it fits snugly inside this grip plate, and then glue it in with CA glue. Also, glue in your nuts. And by the way, this grip screw was around 1 centimeter too long, and again, this was my prototype build, so of course in the actual files, the one that you're going to be printing out is going to be around half the length, so it's only going to be that big. That's why it sticks out so much here. But yeah, then you literally just fit it inside the grip, and make sure that you sand the sides of grip plate so that it doesn't like go in too tight and potentially rip apart the seams. And after that, you could just screw in like 4 screws on the sides, and then put in the grip screw and use it to shim your motor. Now the very last part is simply to glue on your muzzle brake. So there's a few ways you could do this. If you want to paint your gun, then do it now. So just take apart like the handguard section and the inner and the outer barrel and paint them separately, and then reassemble this handguard section. And if you want to disassemble it again in the future, then you have to glue the muzzle so that it glues only onto this face of the handguard. And the reason why is that otherwise, if you just glue it onto the outer barrel, then you won't be able to pull the outer barrel out if you want to disassemble it in the future. For me, after I paint my gun, I'm not going to need to disassemble it because this part is never going to have a mechanical failure or need replacement. And even if it does, I'd probably be willing to reprint this whole handguard section. The way you print this is you print it standing up on this face, and you need to have supports for these overhangs, otherwise they'll look messy. And print it with 4 walls and 100% infill. And when you glue this, first sand it flat so it's a nice flush area of contact where the glue can bond properly. But yeah, this is like the end of your build, and enjoy, and thanks for watching.